So, the reason I'm making this video is I want everyone to know exactly how I'm doing this, exactly how it's done. I like for everybody to replicate it, and so we're just gonna go through everything. But just want everybody to know that in order for us to succeed, that we all have to work together. And all the names around that board there, my name's right here. We all worked on that and helped each other in order to bring that in and make that happen. Check this out. Pretty cool, huh? So just like before, the only difference is I actually changed the lines around instead. Now I've got that little bitty wire running along the wall up here. It's going all the way around back over there. And you seen I had my hand in that water and it wasn't hurting me. But anywho, so let me explain how this is done. Okay. So here's the circuit. Okay. Now it's so simple. It's it's gonna blow you away. So here's how it works. This is the simplest, easiest form of the circuit that I can show, and I'm going to try to explain this and help you understand what's going on. So, basically here is this is just a furnace ignition transformer, and it takes the house 120, steps it up to 10,000 volts, and the outputs go to a spark gap, okay, and then to then to a set of doorknob capacitors, okay. Now coming out the other side of the doorknob capacitor are the metal rods, the copper bars, okay. That's what these black lines are, okay. Now we all know this. This is the conventional. We've all seen this, okay. But over here, see what makes this possible, this dielectric round. See, the electricity is coming from the dielectric round because the energy is coming from where you see this blue line, okay, right here. This is what's making all this happen over here, because it's coming from the dielectric part of the capacitors. Here is the capacitors that are splitting the circuit here. You can have a dead short on this circuit right here. That's if you want to put a dead short across there, it'll still run just fine. But without the dead short, you get a lot more brilliance in the light here. Now there's a lot of different things you can do to to change this, you know, the thing that I'm doing right now is adding a mechanical spark gap so that we can adjust the circuit till we get it to a resonant point. And Tesla said that there was about 5 different types of energy that can come from this particular circuit, and this is just the most basic form of it, and this will work with just any kind of circuit. This is so long as this is there, the two capacitors, and then the resistance, you can apply this to anything. So I'm trying to, I hope I'm explaining this good enough. So that's the circuit diagram. That's what it looks like. Again, if you go look on the internet for, you know, the cold electricity and stuff, it's all this stuff's out there. But you'll find that Tesla talks. This is what his primary focus was on. I believe that we should try a Tesla coil over here and see what kind of results we get. I don't really have one put together at the moment, so maybe somebody else can try that. But also, you can take 2 caps like this and put a variable resistor in between them and have a really large variable capacitor with a big beefy capacitance rather than like the little mini radio kind. The device here, I'll just show you exactly what I'm working with over here. You can see here's the ignition transformer back there. Just got it out of a junkyard somewhere for free. The only thing I bought was those doorknob capacitors. Well, here we go. Let's see. There they are. So you can see the output of the transformer is coming directly to the one end of the doorknob and then to the spark gap. Okay? And then the other end coming right to this spark gap. So, and the outputs from the doorknobs are going up the bars. Now, I don't have a dead short applied to this because it's shorted because I have the resistance on there, but if I want to, I can always add the dead short in there like that. Okay, so now supposedly this is Tesla's water fuel device, and if you look at it now, the first thing that you're going to notice is you'll see that here, because of this, okay, everything over here is cold. Okay, this is the dielectric ram over here. Okay, over here's the what we're accustomed to, and this is the rotating spark gaps, because you have to, whenever this thing's tuned, the light intensity that comes out of it gets really bright white, and it just takes on a lot of different interesting forms. So there you go. That's how simple this is. I mean, it's really that simple. It's so simple. It's just mind-boggling. You know, I don't know, but so now you know. So please go and replicate it, build it, get it done. Take the tiniest piece of wire you got, and see, again, I've got the wire. See a little tiny piece of wire on that one? Tiny piece of wire there, and it goes all the way up, around, and over to here. And I'll show you that when okay, I'm doing my switch. Alright, here we go. Alright, see, and basically what I've been doing, I've just got it on a remote switch so that you know, I don't have to, I can just hit a button and boom. Now what I'm going to do is I'm going to unattach the load. Oops, I didn't mean to do that. Okay. Okay, alright, wait a minute. I still got it shorted out. Now, what's really interesting is I keep reading Tesla's work and stuff, and they used to take, like when people had cancers and stuff like that, they would take 2 metal plates and put it in between where the cancer was and apply this energy to it, and supposedly it would cure it. I've actually tested, I let this electricity run through me all the time, and it makes me feel really good, you know. I don't know if it's placebo effect or what, but I enjoy it. It's kind of scary at first to stick your hand in that water, but okay, so now the system's not shorted out, so this is what the spark looks like normally. See, that's 10,000 volt spark. Nothing spectacular, right? See, that's 10,000 volts. But when we short the system, now so okay, the other thing I wanted to share with everybody is there's a fella goes by the name of Everybody's Eye, and what I was been wanting to share with you guys is all the pulse motors and everything that we build. If you have a beefy enough type of pulse motor, apparently whenever they're running, if you take and hook your water fuel cell up to the charging side, that it will actually slow down your meter, because every time it pulses, it's pulsing back through the system, but you have to be powering it from a wall wart. You know, like I'm powering this one from that one down there. It's a 120 volt to 12 volts. So every time the power gets kicked back out, you know, there's 120 volt spikes going in the opposite direction. I really like this. It's all like but yeah, there's these 120 volt spikes going in the opposite direction. But you got, and it helps to have the fuel cell hooked up here. But now the other thing. Oops. Anyway, the other thing I wanted to mention was these thermionic tubes. If there's anybody out there that knows a lot about these, I would really like to show some that I have, and see if anybody can help me identify what they are exactly. I've got some pretty unique ones, but I know that Tesla was doing because of the different setups inside of here and stuff, using the radiant or the cold electricity in conjunction with these was a pretty important thing from what I've gathered. So, but anyway, what else did I want to share? Yes. So what I've been kind of working on also is I was trying to maybe use these metal pans here, and I was wanting to use my RF generator to put some waves in there so that they'll reflect back and forth, and try to see if I can figure out where maybe the frequency was where that fellow was able to light that salt water in the tube. So just trying to see if I can figure that out. It's just one of many things I'm working on at the moment. Guys probably know what that disc is for. But I just want to say thank you to Iron D Max, and also, if you guys, I don't know if you've noticed these symbols and things like this. It's basically the geometry. If mathematics was the language of science, then the geometry is the grammar. And this fella, his name is Abraham, and he puts all this stuff out for free. And he has basically went through and broke down everything from electrodynamics to chemistry. You can see how elemental families are put together. You can see how there's just a lot. There's just so much, and the reason that it's so important is because it's based off of these equilateral geometries, or an equilateral triangle, which is a tetragrammaton, which I don't know if any of you guys are familiar. In the Bible, God's name is actually, it was Tetragrammaton. They put the word God in there, but every time you see the word God, it's actually Tetragrammaton. You can look it up on Wiki. And a tetragrammaton is an equilateral triangle. Okay, and if you guys see Nassim Harriman's work, you'll know that, the reason why you see the Star of David or whatever, the 6-point star, is because everything in the universe has polarity. So if you have an equilateral triangle, you're going to have polarity. That's just the nature of our universe. If you're really wanting to, this energy wants to be free, and transmission of electrical energy, signals, anything, it all works 10,000 times better and more efficiently without wires, period. It's just we've got to find out all the answers, and as soon as we figure things out, we got to share it, and just help one another, but that's all I got for you. I just wanted to explain the device. People were asking about it. And if anybody can help me with this idea that I'm working on here as far as reflecting waves back and forth and using this RF generator, this model 606A signal generator, I can pretty much control amplitude, modulation, a lot of different things. It has a crystal calibrator on it, and I can listen and hear like tones and stuff, but I'm just still learning how to use it. By the way, I don't know if actually about 2 years ago I didn't know anything about electronics or anything, I just learned about the water fuel cell, and I seen it as a way that we could repair and fix all the damage that's been done. So that's the reason why I devoted my life to it. But along the way, it's just been awesome. I've had so much fun building all this stuff and learning, and all the exploration and all the different stuff. I just have a lot of fun with it, and I build just about everything I use myself. My power supplies and my tack welder and the little inventions and gizmos, and I still have a lot to learn. And we all do, we're all on a path of discovery. I don't really believe anything's invented. I believe that we're all just discovering together, and if we work together, we can get it done a lot faster. But all right, I'm gonna quit rambling. But these days, this is what everybody calls me, my friends and stuff, because of my love and fascination with electricity. So peace and love to everybody, and give it your all, do your best, and forget the rest. Peace out.